Welcome to myprojectbazaar.com. Our product title is a low power class ABGM based amplifier with application to an 11-bit pipelined ADC. Now we are going to discuss about our process abstract. In our process, mainly we focus the pipelined ADC has been taken the optimal architecture of the multimedia applications required for fine resolutions and low power and high speed. However, the has been the less considered the ultra low power process and power application due to the bias current needed in the operation amplifiers. The maximum sampling rate record for the sensor applications is usually only the few megasamples per second, which is smaller than the typically sampling rate to show the best conversion efficiency with a pipeline ADC. So any type of sensors, we are going to convert the signal to analog to digital converters in real times. We propose the main pipeline of ADC potential candidate for the use ultra low power applications. Since pipeline ADC issue the significant and ADC of the cap DAC's loading and compared to the noise, it would be the regarding the candidates of low voltage and fine resolution of applications. In research of the pipeline ADC has been mainly focused to the design of operation amplifiers as OPAM. As the CMOS technology scales down and we get the design of the robust high gain OPAM became the increase in the difficult due to the low device gain reduce the head force, and the traditional approaches of the cascade process amplifying the generic sufficient gain is improve the CMOS process. Although the still we require the large power and complicated frequency compensation techniques, we have achieved and high effective gain with a low gain op-amp. We have also used and consider the correlated level of the shifting and parallel using of the amplifiers. The extract base of output approximately tight recommend matching the recently processed amplifier approaches zero crossing based circuits. We alternate the dynamic source follow the amplifications and the capacity charges. The ring amplifiers also suffering from the large sensitivity of parameters and temperature variations. The requirement of the complicated calibration cycles have been investigated to reduce the static current without complicated digital control process. The mainly we focus the voltage decrease the class AB schemes significant benefit both speed and power. Let me see our process flow diagram. In our process we have giving the 11-bit analog input for the ADC process, and then the main objective for the pipeline ADC stage we have using the 5 type of pipeline ADC conversion process. Now I'm describing the first pipeline ADC stages. We have get the analog input for 11-bit and it will be give the sample and hold circuits. In the process the transmission gate based the design act as sample and hold circuits. Thus the gate is made up the parallel connections of an NMOS and PMOS. The sample and hold is used to convert the continuous signals into discrete signals, and then the circuit hold the values at constant level for the specified minimum periods of times. Thus the sample and hold circuits are used the analog to digital converters first stage process in the process, and then the analog process after complete the sample and hold circuit we give the comparator process. In our process second stage of analog to digital converters, the comparator circuit is used. The comparator circuit compare the output of the sample and hold circuits with the reference current. We have give the some reference voltage of current and values after digital output, and then This produces the perfect digital output in the final result. Then the output of the comparators is all stage of pipeline ADC is given to the lattice circuits. After the process completed, we go and give the multiplier circuits. In the multiplier circuits, the process the transmission gate based multiplier circuits is used. The multiplexer circuits, the two input are given, then the other sinusoidal input. The control signal, depending upon the control signals, stabilization output is produced. The stabilized analog signals is given the next stage of pipeline ADC. This same process we have given the pipeline ADC stage 2, 3, 4, 5. After finishing the up to stage 5, the same process is given the alternately given, and then performance analyze the closed status. Thus the pipeline ADC architecture consists of 5 stages completed. Each stage the output is given to the latch circuits, then produce the final digital process. Each stage consists of sample and hold circuit, compared circuits of the finally we analog signals is converted to digital signals in pipeline. Let we see our process running procedure. We have implemented and the designing circuit is completed in Canner EDA 13 versions. We have implemented the e-edit process. We have created first cell process. After cell process completed, we have designing the each and every designing process, like using the CMOS and NMOS. This process we are connecting the CMOS and NMOS process. We have considered the CMOS process, and then we create the control process, read and write bit of any process. We have give the input for write 11 bit of the ADC process. Unlike inputs, we have given the 11 bits. After we get the read process in 11 bit from digital signals. This process I have implemented in the circuits, right, little bit hidden. And then now we are going to set up the process. After complete this simulation, this designing process, we are going to the simulation process. So here the transient Fourier analysis we choose, and we have giving some input for the output, like start and stop timing. So here we are giving the same whatever the timing we considered nanoseconds, we give it. After completed this process, we go into the running the process. So in the G-edit of the graphical process, wave edit, we get the output of the graphical output. Here also T-space is a way of using the this is process T-space. We have calculated the power process, and then we edit for the waveform graphical. So this process, and we are giving the analog values, and we are getting the output for the digital values. So what are the we giving the bitwise, we consider the analog to digital converters with using the pipeline. So each and every stage we are using the pipeline. We have using the first 5 stage of the pipeline ADC process. We are showing the process. So analog values, and we get the digital values. So what are the sensors we give the values for analog? We get the controllers. We get it will be get the only for digital output or zeros or ones. After complete this process, analog to digital converters in the pipeline, and then we create the cell 1. So this also we have designed the cell 1 process for the connecting each and every analog digital converters for the pipeline stages here. So this also we have running and get the output for process graphically, W-edit and waveform get it for analog to digital converters. So this process, it will be giving the analog to digital converters at the stage of the 5 stages of pipeline ADC process. So this process we give the analog digital converters using the pipeline ADC in 5 stages. Thank you for watching our product.